Antarctica's first dinosaur fossil was discovered in 1985. There was only one problem. For the next 40 years, nobody knew it was a dinosaur. A geologist picked the bone out of exposed rock on one of the most isolated islands on Earth, labeled it as the remains of a large reptile, brought it home, and placed it into a scientific collection. And there it stayed. Through new dinosaur discoveries, through changing textbooks, through entire generations of paleontologists reconstructing what prehistoric Antarctica once looked like, the bone that could have changed that story was already sitting in a drawer. No expedition needed to find it again, no melting glacier had to expose it. No helicopter had to land beside some impossible cliff. Someone simply had to look at the old fossil one more time. When scientists finally did, the shape of one vertebra forced them to rewrite a small but important piece of dinosaur history. Because this was not a marine reptile, it was the tailbone of a titanosaur, a long-necked dinosaur from the same enormous group that produced some of the largest animals ever to walk on land. And the strangest part is not that a titanosaur once lived in Antarctica. The strangest part is that scientists had held the proof in their hands 4 decades earlier. They just didn't know what they were looking at. Go back to 1985, the place is James Ross Island off the Antarctic Peninsula. Today, the name Antarctica brings up a simple picture: white ice, brutal wind, empty horizons, and temperatures that seem designed to keep almost everything alive away. But the researchers working there were not searching for dinosaurs. They were mapping rock. The British Antarctic Survey expedition wanted fossils that could help geologists work out the ages of different sedimentary layers. Ammonites and other marine organisms were especially useful because they appeared across large stretches of geological time. Geologist Mike Thompson was part of that work. Somewhere among the exposed rocks of James Ross Island, he picked up an unusual fossil vertebra. It was clearly from something large. But field identification in Antarctica is not a museum exercise. You are standing in one of the harshest working environments on Earth. Fossils may be incomplete. Rock obscures important surfaces. The animal may be represented by a single damaged bone instead of a skeleton. Thompson recorded the specimen as belonging to a large reptile. That interpretation made sense. The sediments around it had formed in a marine environment, and the expedition was already recovering remains connected to ancient seas. So the bone entered the British Antarctic Survey collection without becoming famous. No dinosaur announcement, no reconstructed skeleton, no museum headline, just one vertebra filed away among thousands of other pieces of Earth's history. And then 4 decades passed. This is the part of paleontology that rarely makes documentaries. Not every discovery happens in the field. Sometimes the expedition happened before the scientist who solves the mystery even knew the fossil existed. Years after the 1985 expedition, paleontologist Mark Evans was going through the British Antarctic Survey collections when the old vertebra caught his attention. Something about it looked wrong. Not wrong in the sense that the fossil was fake. Wrong in the sense that its label no longer matched what the bone seemed to be saying. Evans suspected it might belong to a dinosaur. More specifically, the shape suggested a sauropod, one of the long-necked dinosaurs. That possibility immediately made the forgotten specimen far more important. Sauropod body fossils from Antarctica are extraordinarily rare, so the team compared the vertebra with more complete dinosaur skeletons discovered elsewhere. They studied its anatomy, its proportions, the way the front and back of the vertebra connected, the shape of structures that once supported muscles and neighboring bones. Piece by piece, the old identification began to fall apart. The fossil was not simply from a generic large reptile, it came from the tail of a titanosaurian sauropod. And suddenly, the date written in the expedition records, 1985, mattered enormously. Because if the identification was correct, this wasn't merely another Antarctic dinosaur fossil. It was the first dinosaur bone ever collected from the continent. Scientists had found Antarctica's first dinosaur before they knew Antarctica had given them. 1. The rock surrounding the fossil carries the story much farther back. Roughly 82 million years ago during the Late Cretaceous, Antarctica was almost unrecognizable. Forget the endless ice. Forget the continent-sized freezer at the bottom of modern maps. The animal represented by this vertebra lived in a world of temperate forests. Ferns grew there. Conifers grew there. Vegetation capable of supporting large herbivores covered landscapes that today seem almost biologically impossible. Antarctica was still positioned close to the South Pole, meaning the seasons would have produced enormous changes in daylight. For part of the year, life endured months of dim winter conditions. Yet, dinosaurs survived there anyway. Small plant eaters moved through the forests. Armored dinosaurs were present. Predatory dinosaurs hunted them. Ancient relatives of modern birds shared the landscape. And somewhere among all of them walked a long-necked animal whose tail would eventually leave behind one of the continent's strangest scientific time capsules. It was not a giant by Titanosaur standards. The researchers estimate the animal was around 6 to 7 meters long. That is substantial by modern animal standards, but Titanosaurs included species that became enormously larger. So, scientists are left with two possibilities. This Antarctic animal may have been young when it died, or Antarctica may have supported a genuinely small-bodied titanosaur. One vertebra cannot answer that question, but it can prove the animal was there. And sometimes, one confirmed presence is enough to change an entire map. There is another strange detail hiding in the rock. This dinosaur was a land animal. Its fossil was found in marine sediment. That means the final journey of the bone probably began after death. Imagine the coastline of Cretaceous Antarctica, forest behind it, ocean ahead. Somewhere inland or near the shore, the titanosaur dies. Its body begins to decay. Water reaches it. The carcass or part of it is carried away from land. Eventually it sinks. Mud and sediment begin covering what remains. The ocean floor becomes a grave. Millions of years pass. Sediments harden into rock. Continents shift. The planet cools. Antarctica freezes. And a tail vertebra from a dinosaur that once walked through a polar forest ends up trapped in marine stone. Then, roughly 82 million years after the animal died, Mike Thompson picks it up. That alone is an extraordinary chain of survival, but the fossil had one more wait ahead of it. 40 additional years inside a collection before its real identity was recognized. Titanosaurs were not obscure experiments in dinosaur evolution. They belonged to one of the most successful branches of the sauropod family tree: long necks, massive bodies, column-like legs, tails that could stretch far behind them. Some members of the group reached astonishing sizes and ranks among the largest terrestrial animals known, which makes Antarctica's tiny piece of evidence unusually frustrating. Scientists do not have a skull. They do not have a complete tail. They do not have limbs. They do not even have enough of the skeleton to confidently assign the animal to a species. They have one incomplete vertebra. But one vertebra can still carry anatomical fingerprints. The specimen shares features with advanced titanosaurs known from other parts of the southern world, especially South America. And that is where the discovery stops being a story about one bone. Because during the Cretaceous, today's isolated continents were remnants of a much more connected southern land system. South America, Antarctica, Australia, New Zealand. Their dinosaur histories were not separate stories yet. Animals could potentially spread through landscapes that later disappeared beneath ocean and ice. The Antarctic vertebra adds another point to that ancient root. A small fossil in a drawer becomes evidence in a continental-scale migration story. Look at a modern map, and Antarctica seems like the end of the world. For dinosaur evolution, it may have been a bridge. Titanosaurs are well known from South America. Evidence from New Zealand also shows that long-necked dinosaurs reached land in that region. The Antarctic fossil strengthens the possibility that dinosaur populations moved through southern land connections, while the continents were still arranged very differently. That matters because paleontologists are trying to reconstruct movements without the benefit of complete maps. Coastlines vanished, land bridges sank. Ice now covers enormous areas of exposed geology. Most of Antarctica cannot simply be walked and searched the way fossil hunters explore parts of Montana, Argentina, or Mongolia. Only limited areas of rock are accessible. That means the Antarctic fossil record is not necessarily sparse because few dinosaurs lived there. It may be sparse because almost everything they left behind is currently locked beneath ice. There could be entire ecosystems underneath it, species nobody has named, evolutionary branches nobody knows existed, connections between continents we have only partly reconstructed. And one mislabeled vertebra suggests how easy it is for even the evidence we already possess to remain invisible. Here is where the timeline becomes almost absurd. Other Antarctic dinosaurs became scientifically famous while this bone remained unidentified. New species were described. Antarctic dinosaur ecosystems became a legitimate field of research. Scientists learned that the frozen continent had once supported surprisingly rich prehistoric life. Yet the fossil collected before those discoveries was still sitting quietly in storage. The first bone found did not become the first dinosaur recognized. History passed it. Think about how unusual that is. Scientific discoveries are normally remembered by the moment someone finds the object. But finding something and understanding something are not the same event. A fossil does not arrive with a label. It does not tell the scientist whether it belongs to a dinosaur, crocodile, marine reptile, or something nobody has encountered before. The evidence is only as useful as the knowledge available to interpret it. In 1985, the fossil entered a collection surrounded by one set of assumptions and comparisons. By the 2020s, paleontologists had decades more dinosaur material available, more species, better comparisons, better imaging, better understanding of sauropod anatomy. The fossil had not changed. Science had. That is why the drawer mattered. There is one part of this discovery that the scientific paper cannot fix. Mike Thompson, the geologist who collected the fossil, died in 2020. He never learned that the bone he picked up on James Ross Island was a dinosaur. He never learned that it would eventually be recognized as the earliest dinosaur fossil ever collected from Antarctica. At the time, he had done exactly what good field scientists are supposed to do. He noticed something unusual, he recorded it, he preserved it, and he brought it back where future researchers could study it. He did not need to solve the fossil himself for the discovery to matter. That is the entire reason scientific collections exist. Objects can outlive interpretations. A fossil that seems ordinary in one decade can become important in another. New questions appear, new technology appears, new specialists notice features. Older researchers could not compare. The drawer was never where the discovery died. It was where the discovery waited. That may be the most important part of this entire story. The vertebra was not hidden beneath 2 kilometers of ice. It was not trapped on an unreachable mountain. It was not discovered by some futuristic machine drilling into Antarctica. Scientists already had it for 40 years. That should make museum collections feel very different. Behind the doors of geological archives around the world are millions of fossils collected across centuries. Some were studied carefully. Some were identified using the best science available at the time. Some received a label and have barely been reconsidered since. Most will probably remain exactly what scientists think they are. But not all of them. Somewhere in those collections could be the oldest example of a known species, the youngest survivor of an extinct lineage, an animal from a continent where nobody thought it lived, a bone assigned to the wrong group, a species waiting for a name. The next major dinosaur discovery may already have been discovered. It may simply not have been understood yet. Antarctica's first dinosaur fossil survived roughly 82 million years of geological change. It survived burial beneath an ancient sea. It survived the transformation of a forested continent into the coldest landscape on Earth. It survived until a geologist picked it up in 1985. And then it survived one final obstacle: our own misunderstanding. For 4 decades, the evidence sat where scientists had placed it, correctly preserved and incorrectly identified. Nothing about the bone changed when Mark Evans looked at it again. Only the question changed. That is what makes this story bigger than one titanosaur. Science does not always move forward because someone finds something new. Sometimes it moves forward because someone returns to something old and asks, "Are we sure?" One tailbone was enough to change the answer, And somewhere, in another drawer, there is almost certainly another fossil waiting for someone to ask the same question,